Okay, if you look at on the previous example that we have discussed here, we have shown that the graph for this vector function is lying on xy plane and we have a quadratic. Okay, so how can you know that the graph is curvy or straight line? It should be from the parametric equation that you have, whether it is a linear equation or non-linear equation. So as you can see here, the function contains the non-linear equation for this one, right? And that's why our graph is quadratic. Okay, but how can you know it is a line? If all the parametric equation, they are all linear equation. For example, as you can see here, we have the vector function f, and then all the equation here for x component, you have x equal to 3 minus t, y equal to 2t, and z equal to minus 4 plus 3t, and they are all linear equations. So meaning that we can estimate, or we can expect the graph that we should sketch later on is a linear equation, because all the equation here are linear equation. Okay, but you cannot just simply sketch the linear equation, let's say, because now you have the xyz component, right? So meaning that your graph should be on 3D. You have a curve in space, so if you draw it, looks like we have that one. We should have a linear equation. We have a straight line on 3D system, but it's not necessarily that you can easily sketch for any direction that you want to, whether that way or this way or that way. So it should be referring to the information that you have from the equation here. Okay, remember last time I mentioned from the previous video about the very basic thing to get the vector function of a line segment or a straight line. Where is it? I think I have already mentioned about it before. Okay, a vector form of a line segment or linear equation. Okay, to get that, you must have, let me find it first. Okay, so in the notes, as you can see here, to get a vector function of a linear equation or lines, you must have there are two important things that you have to have before you obtain the vector function of a line. So you must have the point. Okay, just a second. So you must have the point P naught, which is along the line that you are looking for, and also you must have the vector which is parallel to the line that you want to obtain the vector function. Okay, which means that you must have, in order for you to obtain the vector function of the particular straight line, you must have the point where the point is part of the straight line that you want to obtain the RT, the vector RT, and also you must have a vector which is parallel to the line that you are looking for. So you must have the vector V. Okay, and the point P here is called as the vector the point P. Okay, when you have a point, so let's say I'm using the x naught, y naught, z naught, x naught, y naught, z naught, representing the value of the x, the y, and the z. So this one is a point. So in order for you to obtain the r, so you have to convert the point P into a position vector. Where when you have the position vector, you have to write down to be r naught. Okay, and the r naught, and you convert the point P into a vector form. So it's become, now you have sharp band bracket. I would say this one is sharp band bracket. Okay, so this one, the component of the R naught is X naught, Y naught, and Z naught. Then you have the R naught vector or position vector at this point. So now how can you have the RT? You must use the formula to get the vector function RT, where the formula is given by R naught. It is a vector plus T is a parameter T. V is a vector which is parallel to the RT that we are looking for. So you must use this formula. Okay, so now we go back to the question here in example 4.2. Oh yeah, sorry about my previous video, and maybe for the next video, sometimes I always mention about the subject, which means that math method 1 actually and math method 2 or math method 1 actually you have we have another section that I'm teaching now, where the content are, I would say, exactly the same, but just a different name of the course. So I'm so sorry about that, because I'm using the same material, because actually the content are the same. So that's why I just use the same teaching material. But just to let you know that for sometimes I mentioned about math method 1 or math method 2, meaning that they are all in the engineering maths 1. Okay, actually the content are the same, but just the name of the courses. Okay. Okay, so now we go back to the okay, we have a problem here. So they ask you to sketch. So now we know that we can expect expect that the graph should be a straight line, but in which direction? Okay, because we know that the good thing about the vector function, let's say now we have this vector function, they can also determine the direction. Okay, so now we have to in order for us to sketch the graph, where we should provide the point and also the vector parallel to the line. So now we have to find out these two information from the vector function given. Okay, so as we know that from the vector function, they are always has a parametric equation, where this one we can see the parametric equation of x. So now x equal to 3 minus t, and this one is y, and this one is z. Okay, so that's why we can write down to be in this form. So this is called as a parametric equation. So what is a parametric equation? Parametric equation is the component for the vector function. So this is called vector function, and this is called parametric equation. Okay, so now from the parametric equation given here, we can find out the point that the line passing through, and also the vector v, which is parallel to the vector r. So now the vector r here, we can say this one to be f. Okay, the vector f. Okay, as given. So now we want to rewrite the vector r, or actually it is the same. In this case, we call it as a vector f in more general form. Okay, as I explained from the previous video. So the R naught in this case is, we can say that the R naught is coming from the P, where the value of x is x naught, y is y naught, and z is z naught. Okay, so and we have to find out the vector v. So then so we can, what is R naught? So R naught is x naught, y naught plus z naught plus t. So let's say v, I put in general this one to be v1, v2, v3 for the component. So v1, v2, v. This one is supposed to be vector, right? Okay. So now we write down, we total them up in more general, x naught plus t v1, y naught plus t v2, z naught plus t v3. So now, in this case, our r is actually f, isn't it? So now we rewrite the parametric equation here, because this is actually parametric equation, okay, for the for a straight line, for a line. So we rewrite this in so you can see here, this is multiplied by t. So we have 3 minus t, and y is 2t. So meaning that we have 0 plus 2t, and then we have minus 4 plus 3t. Okay, so now if we relate, so we have 3 plus t and then minus 1, right? Okay, so we just compare this one to in general form with the in general form. So we have 0 plus t2 and minus 4 plus 3t. So we can now obtain that x naught, y naught, z naught is 3, 0, minus 4. What is x naught, y naught, z naught? Now we got the p at x naught, y naught, z naught is p at, now we know the point now is at 3, 0, minus 4. That is the point which is passing through the line. And also we can obtain the v, right? So this is v1, this is v2, and this is v3. So now we can write down our v. It is a vector at the position vector is at v1 is so minus 1, 2, and 3. Okay, so now in order for us to sketch the line, so we know that the line must be passing through the point of 3, 0, minus 4, and the line must be parallel to the vector of minus 1, 2, 3. So now we have to sketch. We have to plot the point and also obtain or label the vector of minus 1, 2, 3. Okay, so now we want to sketch the label the vector and also plot the point P. Okay, so x negative. So maybe I have to follow the x, y, z. And then, okay, so x minus 1. Okay, x minus 1, y is 2. Minus 1, and this is 2. Okay, that is on 2D. And then z is 3. 1, 2, 3. So that is the vector. Okay, so the vector. Now that is the negative 1, 2, and this one is 3. So now we have to label the vector. So that is the vector v. Okay, and then where is the point of 3, 0, minus 1? So 3 at x3. So now we have to 1, 2, 3, 3, 0, So 3, 0 here, and then minus 4. Z is minus 4. 1, 2, 3, 4. So that is the point P located at 3, 0, minus 4. Okay, so you have to take a ruler. So you have to take a ruler and you have to draw a line passing through this point P and parallel to the V here. So now if you take a ruler, so it looks like okay, so that is the line. The line is passing through the point P and parallel to the vector V. So this is the vector R. Sorry, in this case, because they give you capital F, so I have to follow. So we have the vector F. Okay. And then again, what is actually, how can you obtain this graph? Because we know that in order for you to obtain the vector function, you must have the a vector which is parallel to the line of the vector function F, and then there must be at least a single point that you know passing through the line. Okay, and then you answer it. Okay, we have this line, and the line is passing through the point 3, 0, minus 4, and then parallel to the V. And how can you get the V? From the information from the parametric equation that you obtain from the vector function given. Okay, so that is your graph. Okay, now are we answering the question? Sketch the graph? Yes, for all t. Meaning that you have to sketch the very long line, because they say that for all t. Unless if they put a specific t, then you have to follow. Okay, let's say t from minus 1 to 1, then you have to substitute t equal to minus 1 and find the position vector, and then substitute t equal to 1 and you compute the position vector and you sketch for that specific t. Otherwise, you can draw any range that you want to, because they don't mention about that, right? Okay. So these are actually the explanation. How can we get the line? So how can we got that? From my explanation before, where the important thing here, you know how to use this formula. So for your information, this is the formula for you to obtain a vector function of a straight line. Okay, so this is how you construct a vector function from the information given. But in this case, they ask you another way around, which means that they give you the RT and you have to find out the R0 and the V. How can you get that? As I mentioned before. Okay.